I'm Jennifer Coyne, and I lead the global additive manufacturing team here at Wabtec. And I'm here today to show you some examples of 3D printing for the transit rail industry. We have 3D printers all around the world, but today we'll be in our Metal Printing Center of Excellence in Grove City, Pennsylvania. I'm joined here today by Doug Locke, our lab leader, and he'll be walking us through one of our processes called laser powder bed fusion. Overall, can you tell everyone what it is you do here?
Of course. We develop and use 3D printing or additive technology to drive innovation where traditional manufacturing could not. In this space, we have several different types of additive machines to make parts for our equipment and customers.
Exciting. So what's the story on this part?
This bracket is for one of our transit customers that is typically made with more traditional manufacturing techniques, such as welding multiple pieces together. The problem is it's actually really hard to make a quality weld that meets the EN standard at that angle. With additive manufacturing, we can make this as a solid single piece and eliminate the weld altogether.
Nice. I can see how that would make a better quality part more consistently. But I feel like we skipped to the end of the movie. Can you take me back and show me how it's made?
3D printing is a great solution for spares when you don't have an existing supply chain that meets your lead time or quality needs. In this case, we only had a 2D drawing and had to create the 3D model as a first step. In other cases, you may only have access to the actual part and would start with a 3D scan of the part to create the 3D model. So once the 3D model is created, the part is analyzed for printability and the supports are added where they are needed according to geometry rules for 3D printing. Next, the build software takes the 3D CAD data and slices the file into 2D CAD sections. Each of these layers acts as a blueprint to tell the machine where the laser needs to center the metal for each layer. The build file is loaded onto the printer and the laser starts drawing the 2D blueprint on a thin layer of metal powder. The printer spreads another fresh layer of thin powder and the process repeats itself until a full part is finished. Once the parts are printed, there are a few post-processing steps prior to having the fully finished part, including removing all the loose powder, detaching the parts from the build plate, and removing any supports. At this point, the parts can be 3D scanned for dimensional accuracy and final machined where necessary.
Thanks for showing us the process, Doug. Additive manufacturing has become a technology pillar at Wabtec because of its great benefits. First, it provides the ability to combine multiple parts into one, like this one, saving complexity, cost, and improving quality and reliability. Second, it provides speed. It allows engineers to do rapid design and prototyping and get to market faster. Or in the case of spare parts, we can directly print without lead time for tooling creation. We've seen up to 90% lead time reduction in some cases. Third, additive gives our engineers the freedom to innovate in the part design and shape, which is not possible with traditional manufacturing methods. It creates opportunities to develop solutions that would not otherwise be possible, pushing the boundaries of performance for fuel consumption, emissions reduction, weight reduction, and so on. So thank you, Doug, for taking us through this really cool technology today.
My pleasure.